Hi, I'm Anna Jovanovic, and I'll be talking about how braces move teeth. This is going to be in the topic of the physiology of tooth movement in orthodontics. Thank you. Before we get into how braces work, let's briefly talk about why teeth move in the first place. There are three main types of tooth movement. One is physiological, two is pathological, and three is orthodontic, which is what we'll be focusing on today. So, physiological tooth movement is natural, small adjustments that happen daily, such as during chewing or aging. Pathological is caused by trauma or disease, such as periodontitis or tooth loss. Orthodontic movement, which again is what we're focusing on today, is controlled and intentional movement, and this happens using appliances like braces or aligners. Now let's look at what we actually need to make orthodontic movement happen successfully. There are three essentials for tooth movement. One is optimal force. Too little force won't stimulate movement. Meanwhile, too much force will cause damage and delay progress. It is because of this that we need the optimal amount of force. And the second condition is time. So we need the optimal amount of force over a sufficient amount of time. So this force has to be applied continuously over days or weeks in order to activate the biological process. The third condition is bone remodeling. The tooth will not move unless the bone is resorbed on one side and rebuilt on the other due to the force. Studies suggest the optimal force should be around 20 to 26 grams per square centimeter. This matches the average capillary pulse pressure. That way, blood supply is preserved and bone remodeling can happen efficiently. So, what happens when that force is applied? The periodontal ligament, or the PDL, will sense that pressure. The PDL is a soft, cushion-like tissue between the tooth and the alveolar bone. As it responds, the surrounding bone will start to remodel so that the tooth can shift into a new position. This movement follows the pressure-tension theory. If the force is being applied to the right, then on the right side the PDL is being compressed. This is known as the pressure side. On the pressure side, the bone is being resorbed. Meanwhile, on the opposite side, the PDL is being stretched like a rubber band. That side is known as the tension side, where bone is being added or formed. It is in this way that the tooth gets pushed and pulled through the bone. Now let's look at the pressure side. So the pressure side during compression, when force is still being applied in the same direction, will cause the PDL to compress down to about 1/3 of its normal thickness. This will cause restricted blood flow. You can see this through the thinner and smaller blood vessels. The restricted blood flow will cause an attraction of osteoclasts, which are the cells that are responsible for breaking down bone. If the force is just right, then these cells resorb bone right next to the ligament. This is called frontal resorption, and it's the most efficient way to move the teeth. And again, here is the PDL being compressed down to about 1/3 of its original size. Meanwhile, on the tension side, the PDL stretches. As the PDL stretches, the blood flow increases. This increase in blood flow can be seen by the thicker blood vessels. Additionally, this increase in blood flow attracts osteoblasts, also known as the bone-building cells. The osteoblasts will lay down new bone so that the tooth stays stable in its new position. But if too much force is applied, then the PDL on the pressure side gets crushed, and on the tension side, the PDL gets overstretched. So again, on the pressure side, the PDL gets crushed. This causes the blood vessels to collapse, which makes us get something called hyalinization, which is when the tissue dies due to a lack of blood flow. In these cases, the body can no longer do frontal resorption because it becomes a necrotic tissue. Instead, it has to work around the dead tissue with something called undermining resorption, which takes longer and is less ideal. Meanwhile, on the tension side, the PDL is overstretched, which means that the blood vessels were torn from overstretching. Tooth movement happens in 3 biological phases. The first phase is the initial phase, which happens in the first 1 to 2 days. Here, the tooth will move slightly in its socket from PDL compression and bone bending. And you can see here that when the tooth is moving in the same direction due to the force, the tooth will move slightly in its socket, the PDL will be squished, and there will be bone bending. Next up is the lag phase, which is in about the next 2 to 4 weeks. The tooth will stop moving while the body clears out any damaged or hyalinized tissue. So here again, you can see as the force goes in the same direction, there will be no movement, and there will be osteoclasts, and not osteoblasts, but macrophages as cleaning tissues. Third is the post-lag phase, which happens after 4 weeks. Here is where the real movement begins. The osteoclasts will resorb the bone on the pressure side, and osteoblasts will deposit the bone on the tension side. So here you can see that the tooth is moving steadily. The osteoclasts and osteoblasts are resorbing and depositing bone on their respective sides, the pressure and tension sides,